Perfect. How are you all today? Have you ever wondered what are random variables and how they can be used in engineering? It's coming up right now. I'm Prashant from Dharini Academy of Technical Education, Bengaluru. We'll be discussing about random variables now.
So next we'll start working on the problems based on the normal distribution. So we have seen the standard normalized function of the normal distribution denoted by phi of z. Phi of z is equal to 1 over root of 2 pi integral 0 to z e to the minus z square by 2 dz. This particular phi of z represents the area under the standard normal curve between a specific region, that is 0 to z. Okay, so I'll write one feature here. This is important. Okay, this particular phi of z represents area under the standard normal curve from starting from 0 till z. Right, so we have a table called normal probability table, right, where each of the z possible values have been mentioned, and you can actually find out any phi of z directly from that. Okay, because it's not possible to solve this integral, right, whenever it's required. So the standard table is directly available. Okay, we use the table to calculate this, but before that we need to know some very standard results now. Since the phi of z is the probability function, right, we have to apply the minus infinity to plus infinity into phi of z dz should be equal to 1, because it's a PDF. Phi of z is a PDF, right? Then also it is symmetric, so we can apply a property of symmetricity, that is minus infinity to 0 phi of z dz should be equal to 0 to infinity phi of z dz. And what should be the value? It should be equal to 50%, so half. Right? And then we write the standard notations which we are going to use, that is the probability that minus infinity less than the z less than infinity equals to how much? So minus infinity to infinity means I have to integrate minus infinity to plus infinity. That value we already have found, and its value is equal to 1. Okay, that's correct. Then if I want to find out the probability of minus infinity less than z less than or equal to 0, this is one case. This means this is equal to, I can actually rewrite this as probability that z is less than or equal to 0. That means this is equal to half. Similarly, if at all we want to find out probability 0 less than z less than infinity, this is the condition that probability that z greater than or equal to 0. That's also equal to 1 by 2. Right? Okay. Now, let's say we want to find out a different thing, that is something like, if at all I want to find out p of minus infinity less than z less than or equal to any specific value z1, okay, then this means, let us assuming the z1 to be a positive quantity, right? What I'm supposed to do here is, right, I'm supposed to do the calculation. When we do that, I can write p of z less than or equal to 0 plus, right, the probability that 0 less than or equal to z less than or equal to z1. But I know this part, right? This is equal to already half, right? This part, the second half, I can actually look at the phi function, which is a table of value z1. Okay, right. This is the general way of representation of the given question by using the phi notation, and the value of phi of z can be obtained from the graph. Okay, let's go for another one. So say something like, I want to calculate the probability of z greater than, say, some other value z2. Okay, greater than that I want. Greater than that means it can go till infinity, right? But I know the value only till 0 to z2, right? Which is on the right side. Greater than that. How do you represent this problem now? We can represent this using this notation. So P of, let's say z greater than or equal to 0 we calculate. That is the complete right side. From that you subtract this minus P of 0 less than or equal to z less than z2. So this is nothing but, this is 0 0.5 or half, right, minus the phi of z2 you can write. So just see the difference, right, between the above one and this particular equation. Yeah, look at, we exactly have to look at the whatever z value we want on the table, right, and in the table we get a value, specific value over there. Okay, yeah. So let's try to find out something from the table itself, right? Let's get familiar with the table so that we can apply that when we come to a problem later. Okay, right. So let's try to find out. Let's say we got a z is equal to 1.55, and let's use a table to calculate the phi of 1.55. This is 0.4394 directly coming from the table. Okay, now uh, this is something like, we are trying to find out the probability, right, that 0, so we can write this as probability that 0 less than or equal to z less than or equal to 1.55 equal to 0.4394. Directly from the table we are writing this, correct? Now Let us say I want to calculate this value. So next one, let z is equal to minus 0.86. Okay, and we want to find out the value like this. What is the probability that minus 0.86 is less than or equal to z less than or equal to 0? I want to find this. Okay. Now there is no entry on the table which is negative, right? We use the concept that the give it's symmetric, right? If at all I calculate the 0.86 value here, and if at all I calculate the area, that area is corresponding to this, right? Same thing will exist even on this side, right? This is minus 0.86 and this area is equal to this area, right? So what is the probability that minus 0.86 till 0? If you want to find this, I use a table which actually gives me the value on the right side, but since it is symmetric, I'll do the same. I'll use the same. Okay, same table can be. So this can be calculated by using phi of, it's right there. This is phi of 0.86 from the table. So this value is equal to 0.305. Alright, let's go to another scenario now, wherein I want to find uh, this value, that is probability that minus 0.44 less than or equal to less than or equal to 1.76. Okay, so now that means we can calculate this particular answer probability by just adding phi of 0.44 plus the phi of 1.76. Okay, this is the required probability. Let us say we want to calculate now probability that 0.57 less than or equal to z less than or equal to 2.49. So we'll write this as phi of 2.49 minus phi of 0.57 equal to 0.7. Right, then now let's try to find out a scenario where I want to find probability of z uh, greater than or equal to minus 1.96. So we can write this as this is equal to I can write phi of 1.96 plus 0.5, correct? 0.97. Okay, right. Now probability that z is less than or equal to minus 2.43. So we can write this as zero point 0.5 minus the 5 of 2.4, correct? Okay, this is equal to, okay, this is correct. Then probability that z is greater than or equal to 0.85. Okay, so this gives a value 0.1977 and probability of z less than or equal to 1.94. This is 0.97, right? Okay. So like this, when we actually go to the solution of the random variables based on standard normal distribution, we get a z ultimately. All the z possibilities we solved here. Okay. Like this, we just have to refer the table and find out some area under the curve depending upon the value of z we obtain from the problem. Okay. Now, from the given problem, how to obtain a z is what we have to see when we solve the problem, actual problem. The rest half of the portion is this itself. Okay.
That's all for the day. Feel free to contact if you have any doubts related to any topics in engineering. We can also help you in solving your assignments, projects, and many more. Thanks for watching. Good day.